So the nice thing about this section is that we've really learned it all already, right? If you look at the shapes you see there, parallelogram, rhombus, rectangle, square, and trapezoid, we've learned all those properties. We know about those shapes. So this is just a review of the properties that we've already learned, and then kind of a pulling it together, and we'll talk about that when we do the chart. So just looking at the shapes one at a time, you see the parallelogram here. You notice the opposite sides are equal. Notice that the opposite angles are equal. It doesn't really show the fact that the angles next to each other add up to 180, but we know that, right? We know if this was like 120 and 120, that this would be 60 and 60, and we know the diagonals, if we drew them in, would bisect, and so on. Rhombus here, we see the equal sides. Rectangle, we see the right angles. Square, we see the right angles and the equal sides, right? And then, of course, our newer shape of the trapezoid with the two bases there. So we're going to look and just, it says write yes in the box, but I'm just going to put an X in the box if it has the property. So which shapes have 4 right corner angles? Do parallelograms? Not necessarily. What about rhombuses? Not necessarily. What about a rectangle? Yes, a rectangle always has 4 right corner angles. And what about a square? Yes. So if it doesn't always have 4 right corner angles, we don't check it. Which shapes have opposite sides congruent? Again, you can look back up here at the pictures. I'll erase my marks here and see which shapes have opposite sides congruent. What do you think? What about a parallelogram? Yep. What about a rhombus? Yep. Rectangle, yup. Square, yup. And in fact, anytime you put an X in parallelogram, you're automatically going to put an X in rhombus, rectangle, and square because those are parallelograms. Number 3 says which ones have perpendicular diagonals. So when you draw on the 2 diagonals, that you get a 90-degree angle. And you're right, this would be rhombus and square. Those are the properties of a rhombus and one of the properties of a square. The congruent diagonals, where this whole diagonal is congruent to this whole diagonal, that's in a rectangle and also a square. Because a square, remember, is a special kind of rectangle. I'm going to erase again. I'm going to zoom down here so I can see the rest of them. What do we have next? 4 congruent sides. I think you'll agree that the one that has 4 equal sides, well, ones, there's actually 2. Everybody always remembers square first, but which other one has 4 equal sides? You're right, rhombus has 4 equal sides. Number 6, diagonals bisect each other. That's one of our main properties of a parallelogram. We learned that like right out of the gate. Diagonals bisect each other. So if it works for a parallelogram, it's going to work for a rhombus and a rectangle and a square because those are parallelograms. Same thing with consecutive angles supplementary. That's one of our first properties we learned for a parallelogram, so it automatically goes for rectangle, rhombus, and square. The diagonal bisects the corner angles. That's a rhombus property that's repeated in a square because a square is a special kind of rhombus, right? So if we put in the diagonal, remember how we got the mini 45s in the square. Same for the rhombus. Not always 45, but bisects. This one's tricky. Figure can be named a rectangle. Of course, a rectangle can be named a rectangle. But do you agree that a square is also considered a rectangle, right? Because a square has 4 90-degree angles, which is all you need to be a rectangle. And then not to be left out, the figure with only 1 pair of parallel sides, that's our trapezoid. So trapezoid really is kind of its own thing. Even though it's a quadrilateral, it doesn't fall into the same category as parallelograms. You've seen Venn diagrams before, right? Venn diagrams back in elementary school, you have 2 kind of bubbles, and wherever the bubbles overlap is things that are common between both bubbles. So what I like about this visual is it shows us parallelograms as kind of a big category. And then a subcategory are rhombuses and rectangles, with rectangles having all right angles, rhombuses having all equal sides. And then they overlap with a square that has all equal sides and all right angles. So a square is like the rectangle and rhombus put together. all squares are rectangles. This is a true or false question. Is every square in the rectangle bubble? Yes. Or another way to say that is all squares have all right angles. An easy way to do these problems is to replace the second word with a definition. So the definition of a rectangle is has 90-degree angles. Do all squares have 90-degree angles? Yes. Do all rectangles have all equal sides and all 90-degree angles? Does every single rectangle have all equal sides and all 90-degree angles? No. And it says if it's false, draw a counterexample. In other words, draw a rectangle that's not a square. So here's a rectangle that's not a square. Next one, are all parallelograms rectangles? Do all parallelograms have 90-degree angles? No. Can you draw a parallelogram that does not have 90-degree angles? Yes. So any of these parallelograms kind of floating out here are parallelograms but not rectangles. True or false, all rectangles are parallelograms. Do all rectangles have parallel sides? Yes. And you can tell from the bubble here, every rectangle is in the parallelogram arena. Similar to number 11, are all squares rhombuses? Also true, because all squares have 4 equal sides. That's the main thing about a rhombus, so that's always true. But do all rhombuses have 4 90-degree angles? No. Can you draw a counterexample? Can you draw a rhombus that does not have 90-degree angles? Sure. We do this a lot where we have like 2 questions where they just like flip-flop them, right? One will be true and one will be false. All rhombuses are parallelograms is true, right? Every rhombus here is inside the parallelogram arena. But is every parallelogram a rhombus is false. And again, every false one you'll have to draw a picture to show. So here's a parallelogram that's not a rhombus. It has equal opposite sides, but not all 4 equal sides. You do have questions like that on the test. You do have to draw a picture if it is false. So this is our wrap-up section, wrapping up all our shapes.